So I've been reading this book called Formula One Technology, and I found this interesting insight into theoretical power. So theoretical power is the constant, K1, which I have interpreted as the equilibrium constant, multiplied by the theoretical flow rate of O2, oxygen, multiplied by the theoretical calorific value of the fuel burnt. So for the constant, we're going to assume that the reaction is an octane reaction. It doesn't say in the book, but I'm just going to assume that it's an octane reaction. So the octane formula is 2CH18, which is octane, plus 25 O2, which is oxygen, goes into 16 carbon dioxide, CO2, plus 18 water, H2O. And so because there's two octanes in the reaction, I'm going to simplify it and make there one octane. So there is one C8H18. So everything in the equation is divided by 2. So now there is 25 over 2, O2, and there is now 8 carbon dioxides plus 9 water, 9 H2Os in that equation. So the calorific value of that equation is 5,464 kilojoules in the equation. So in a combustion reaction, which is this, fuel plus O2 goes into carbon dioxide and water. So the constant for this equation should be, so this is C in the equation, so there's 8 carbon dioxides going into this equation, so 8 is C as such, and now there is 9 waters in the equation, so water being D as above, and there's 1 octane in the equation, so it's octane to the power of 1, and now there is O2 to the power of 25 over 2. Now we put these in their molecular level, so we put in however many moles are in the equation. So 1 mole is 6.023 times 10 to the power of 23 atoms, which is Avogadro's constant. And so to simplify the equation, we're not going to put any crazy numbers in the bottom because of the crazy power. So we've got O2 being 1 mole, octane being 1 mole, H2O being 2 mole, CO2 being 0.5 moles. So add that all, put those values in that equation, having, so 0.5 to the power of 8 times 2 to the power of 9, that's going to be 2 on the top line, and we're going to have 1 times 1 to the power of 25 over 2, so the constant is going to be 2. So in this book,